Then also welcome from my side. I would say we goes directly to the new functions inside MDESIGN board. It's in a new format today that we make a presentation for new functions. Normally we doesn't do this, but the step from the 2024 bold calculation module to the new one is a really big step. We have a complete new calculation method and also the modeling in the future for you by using MDESIGN bold 2026. You must know some background information that you can make a good modeling in the future. So I think it's really a good thing to show it you, and so it's more easy for you in the future to use the new functions. So I will give you an overview over the new functions with two sheets, and then I will go directly to the new calculation module to show it in the calculation software. So we have a complete overhaul over the 3D assistant. The 3D assistant also was available in 2024, but not in the full functionalities. Now it's full functionality, and you can make the modeling complete inside the 3D assistant. So it's really easy to model. It's more easy because a lot of difficult inputs for the VDI model are not more necessary to input, because by inputted 3D geometry, this inputs can be directly determined by the calculation software himself. So it's a special recommendation from my side. Use the 3D assistant in the future. It is a help for you, of course. Then we have a new calculation method for a complete new method, integral calculation approach for the pressure body. This what you see in the left picture here. That means it's not more simple geometry of cones and cylinders. Now it's free geometry. That means you give the geometry by the parts, and with this integral approach, you see the pressure cone will be really close to the real pressure cone in the praxis. So it's really important to make the modeling exactly that the pressure cone can create like in the picture here. You see, of course, we have pressure cones in two different directions, not more equal in all directions. So also elliptical pressure bodies are possible, and also the calculation of the eccentricity of the pressure body will be done automatically, because out of this created pressure body, of course, the calculation module can see where the pressure cone is cutted, where is more pressure, and so it will be calculated from this integral approach. So this is a really new calculation method, and we have automatic determination of a lot of other model parameters, which makes problems for new customers. So it's more easy in the future. For example, how many internal interface works for the transfer load, or what is the distance for the actual force, and the special values for the load and reduction factors. All this information will be determined automatically by modeling in the 3D assist. Okay, so we have a lot of new elements inside. You can use now really elastic elements like spring washers, logging edge disk, and NSK disk. This is a special elastic elements often used, for example, in railway technologies. They have a nonlinear material behavior or nonlinear spring behavior, and we get the real behavior from the manufacturers and included in the database, and you can use it. It's really complicated in the calculation because it must be iterative, using the VDI steps, because the elasticity of the elements depends on the preload, and the preload, of course, depends on the losing preload by embedding, and this, of course, depends on the elasticity on the elements. So, of course, only iterative using is possible to get the real situation. So you can use it. You can also in 24 you can use spring washers, but only under the head. Now you can use spring washer and all these other elements under the head and under the nut. And also new are wedge lock washers, like from also we have manufactured data from Nordlock and Heikolock. So you have all information in the database. What are the friction values under the head by using these elements, and what is the geometry? This is all data-based. We have new types of screw and nuts, for example, flange nuts and self-locking nuts, and some more screws, of course, and bolts. For example, also a simple hook screw, if you only want to calculate is the thread safe or not. Such cases are now possible. And we have included the VDI 2023 part 3. There we have the information what is the correct introduction for mounting or assembly. Up to 24 we have only the output of the maximum tightening torque. With this VDI part 3 we have a complete introduction with the range and the nominal torque, so you must give to the mounting personnel. And if you use angel control tightening, it was a missing part in the science, of course, because no technical standard or no other rules exists how to determine the pre-torque and the angel for tightening torque. Okay, so and finally the mounting sheet I will show directly in the calculation software. So I jump to MDESIGN, I switch to English, it's already done. And you see its input side is empty, so we start from the beginning, and I jump directly to graphical assistant, and I will create the VDI model by building the real model, and the VDI model will create it automatically from this real model. So for example, you can use round and rectangular plates. If you want to create a small distance of bolt to one border and cutting the pressure cone, then you must use this rectangular plates, because this you can, you see, with this value you can say this is more close to the outside border and then of the other side. So maybe I choose 3 plates and a third one, and this, and the bolt will be always on the Z axis, of course. So by you choose a bolt from database, for example, standard thread, and I choose arm 12, length 80, for example. So you see it's on the Z axis, and now it's with a thread in the last part. If you add a nut, of course, then it will be automatically, you see different nuts in the database, so to get a database choice. So it will be automatically a through taped connection, of course, thickness 20. So, okay. And in the first step now I can check, is there a cutting of the pressure cone? Therefore you see this icon, you can create now the clamping situation. You see by using this, you see now he used the integral approach to get this pressure body, and you see of course it's cutted on the left side because the bolt is close to this side, and so we get such a little bit elliptical pressure body, and as the eccentricity assume will be calculated automatically from each part of the pressure cone. So then I can choose, for example, washers. You see washers, expansion sleeves, spring washers, edge washers, wedge lock washers, and NSK washers. And for the loading situation, I use radial force, and I can say where is the clamping, for example, or the boundary condition fix. You see it's on the first billet. So when I accept now, it comes to the input side, and you see, of course, there is the bolt, the plates. I don't input a value for FQ, forgot it. So I use this second part, radial force on this, and I must input a value, for example, 3000 Newton. And now, of course, the complete load must be to the boundary condition fixed on the third part. And for example, for this, he says automatically number of transmitting interface is 1. If I choose the upper plate, for example, also as fixed, then automatically he can use 2 interfaces. The transfer load will divide to the upper and the lower interface, and when I choose accept, of course, you see automatically 2 interfaces will be used. And also for the axial forces, the inputs for the load introduction factor will be filled automatically. We have new the mounting group. Here you should use in the future range of the tolerance of the tool. From the range of the tool, range of the mounting will be calculated, and to choose the, for example, tightening torque with a quality middle. And you get, of course, also the informations of middle. Maybe some generally functions of MDESIGN. I think a lot of people today are not confirmed with MDESIGN. It's new for them. You get for each calculation of mechanical element a calculation module, like here for bolts. You have the input side with all necessary inputs. You have the text help buttons to get help what I should input, for example, for the quality here for tightening torque. You get informations in which case you can use a high quality and a middle and a low quality, for example. And you have the database buttons, so you can directly jump to the database and, for example, use a strength rate. And there is one more button. This is the graphical button to choose a thing directly in the picture. So what is also new? It's also new to, I forgot to choose the materials, of course. I must choose the materials. We have still the different databases, MDESIGN database and FKM database, company database if you don't find your material in both databases. So I choose simple material, calculate, and he sees in determined eccentricity. And so he switched to eccentric clamping, of course, and I get now all results on the output side. Of course, summary with the most important results, and then all results as an array for the minimum and the maximum clamp load. You get now a new also all pressures between all interfaces, not more under the head and under the nut. Now between each interface, the pressure, the area, the safety, of course. And you get the group tightening torque for the installation introduction or mounting introduction. This is new from VDI part 3. You get now, you see the maximum calculated torque is 109, but for the mounting personnel, you must give this introduction, use 100 Newton meter plus minus 9 Newton meters. Okay, and you get the material informations. Also new or not is the diagram for the functionality. This functionality was up to 24 in 2 beams. Now it's more easy to read. You have to look to the yellow beams. This must be, of course, inside the green range. Is it too high? It goes to the rising the pressure under the head, for example. You see it's very close to it now, 1.01, but it's okay, because the reality is somewhere between these both values. And the safety against slipping is somewhere between 3 and 6, also no problem. For example, if you use material which has a smaller strength, for example, such stainless steel, then you see it's of course a problem. We have too much force inside, and we goes to the red area. So maybe I also input the actual force. Then we see it better in the functionality diagram. So okay, so it's all fine. You see, if I use better material, then we have the problem that we rise the surface pressure, and maybe we use a little bit less tightening torque. Then we came in the back to the green area. Therefore, we can also use AI functions. You see, here we have the safety against yield points, no problem. Safety against slipping is no problem. Only the safety against rising pressure is a problem. Now the suggestion is less utilization torque. It's not, and you see it will be better. Finally, we must speak about the new function of the form. This is for a better communication between the manufacturing personnel and the construction. That means you make the calculation, you get the installation instruction and all informations for the mounting personnel. So, for example, which tool must be used. You can add, and skew surface will be automatically used in the future. And maybe the personnel had to use a special lubricant for the tightening, for the mounting. So maybe MSO2 or tightening, and then you get a tightening factor. The most important informations coming from the calculation. You have I switch to English, tightening introduction. And with this tightening introduction, the personnel can mounting for the joint. And later, it's coming soon, is that the lower part of the document. Here the mounting personnel must include some informations. For example, special for railway technique, we have for the new European standard a special studies for high quality mounting. That means we need additional classification. We need, for example, for tightening with torque, we need additional value for tightening process. That maybe can be done by the angel for tightening. And this information, the tightening personnel will be right in the lower part. And then the final decision, is it a good mounting process or not, will be in a checkbox. And so we have the full documentation from calculation to the mounting of the bolt joint. And more technical standards will be going in this direction, that it will be a data for you, that you make a documentation not only for calculation, that you also make the documentation of the tightening process. Okay, so the example, I will show you all new function with own example. The special example here from the VDI B5, maybe I can discuss with you up to the calculation of 24. You must working on the VDI model. That means you must create a round geometry for the pressure cone, and you must create a rectangular geometry by the distance E. For the gapping, that's the no gap, that's special calculation. New in VDI and the new model, we use the wheel geometry. That means the upper part will be this and the lower part this, and a sum will be calculated automatically, and it's not necessary to use additional round geometry. The new integral approach will build this elliptical pressure cone. So I can show you. So a lot of decisions are not more necessary. I show it in MDESIGN 24 by using this example. It's example B5 from VDI. We must decide, is it eccentric or not? We must input a sum by yourself. We must input the round geometry by dA. We must input C and B for the bending moment. And we must decide, is there a washer? And we must also decide by the loading what load case is used. Is the eccentric of the pressure cone in the same direction like the eccentric force, or in the opposite direction, and so on. And you must choose AK for the distance from the load introduction to the border of the head. So a lot of choices which are difficult if you don't are really good informed in the VDI standard. And now we make it again with the 26 model. You see, it's more easy. We choose a plate, input the thickness 35, the dimension in Y direction is 36, and in X direction 42, and there is a small gap in the X direction. And I choose the second plate, now 35 and 36. And I choose the bolt, hex cylinder head bolt with standard thread M20, length 60. And this will be on the Z axis. And then, of course, we see again, there is a cutting of the pressure cone. There will be a sim, definitely. And we can choose this side for the axial force. We use it and bring the axial force there. We have 20,000 Newton dynamic, and we can calculate according NXC or standard by, and you see AK will also be calculated. So simple modeling the plates, modeling the force, modeling where the force is working, and modeling which part is fixed. And then you have all information for the calculation. By choosing accept, saving no, we have the information on the input side. It's all filled, automatically filled. We have the loads, we have which plate are fixed, whereas the load introduction, AK will be calculated. And so it's really easy. I forgot again to choose the materials. It was construction steel S355. And so you have, as you see again, it's eccentric clamping, and you have so very fast the modeling and the complete calculation. It's very simple now. I have a tightening factor you must choose. Okay, so it's really more easy to use the graphical assistant. For some people working a long time with MDESIGN, maybe it's completely new, and you are used to working in the standard input side, but try it, and I see you will see the advantages by using the graphical assistant, of course. Okay, so we have new load, so new elements, this or new. Okay, maybe one thing I can show, for example, if you want to make the calculation only of the thread of for a hook bolt, for example, thickness 5. So you can choose such a hook bolt. It's not in the database, only the thread comes now from the database. And can make the calculation with a load on this directly working on the bolt, and you make only the calculation of the thread. This is a typical usage. Or also for hydraulic, you can use this kind of bolts with pressure inside, and there's will be also the calculation done against losing the function of the thread. So try, you have a lot of new function and not a few bolts and screws, and maybe it's really useful for you.